I will very briefly run through the anatomy of a shader section of the workshop. This is less like a formal introduction to shaders and more of like how I think about shaders and thus what I will be bringing to the workshop today. So the way that I think about it, a shader is a program that runs on the GPU rather than the CPU. So when we write P5 or when we write scripting in Unity, all of that is on the CPU, which is good to do one thing at a time and also good at communication. So the CPU can talk to printers, can talk to the hard drive, can talk to the GPU and all of that type of stuff. And importantly, it can store information, it can store memory. Whereas the GPU, it can do a lot of things at once, it's parallel processing, but it sucks at communication. So the GPU processes many things at a time, but it sucks at communication. It only really can receive information from the GPU. It can't talk back very easily. It doesn't communicate with anything else other than the screen. And I'll talk about why that's important in a second. Why it's important is because the way that I think about it is you set up your scene in Unity, you tell the computer where everything is, and you set up your geometry, your models, and the positions of all of those things. And then Unity sends that information to the GPU, which processes it once per frame and forgets about it. So anything you do in this GPU is not like sustainable. You can't access that information later. There are ways that you can get around that, but for our purposes today, it's a fire and forget type of thing. And the order of operations is the scene sends it to the vertex shader, which arranges the 3D geometry in your scene into a 2D image and takes into account things like layering and transparency. And then that gets sent to the fragment shader, which some people call the pixel shader, and that's a pixel by pixel processor. The kind of two things that you get out of this is that the pixels in the fragment shader can't talk to each other. So things like blur, effects that involve like knowing what other pixels are doing at the same time, are difficult to achieve. And the other thing that's important is, I already mentioned that things aren't saved. So you can change the geometry using the vertex shader, but you can't necessarily save it. Moving on from the general idea of a shader, what is Shadergraph? The Shadergraph is a visual interface for creating shaders. So instead of writing lines and lines of intimidating code, it's a nice way of creating images and dragging and dropping nodes. It does have its own learning curve, and it's not super intuitive, which is why we're all here today. But it is less intimidating, especially to beginners, than just seeing a single file full of thousands and thousands of lines of code. All right, so that's the end of my spiel. Does anybody have questions based on shaders and or what the purpose of Shadergraph is? Because if not, I'd say let's go ahead and open Unity. I'm going to go to my hub, and Shadergraph does not work by default. Let's create a new... So some people who haven't looked into the rendering behind Unity before, this might be new to you, but when you open up 2019.3 point something later, when you create a new project, this is what you're going to get as a sort of interface. Does anybody not see these 5 options here? Okay, cool. Everybody sees the options. Each project that you select here will just set up Unity in a slightly different way. And the two that change a lot because they're still in development are the high definition render pipeline and the universal project template. To get Shadergraph to work, you can't be using the traditional 3D renderer. You need a scriptable render pipeline. We don't have to get into what that is, but it's just a way of customizing your own renderers in Unity. HD is for things like if you're creating PlayStation console games or something that works on a high-end PC. And then Universal Project Template, as far as I understand, this used to be called Lightweight Render Pipeline. This is kind of Unity's way of saying like it can work on anything. So whether you're dealing with web graphics, mobile graphics, stuff for VR, UPT, I guess it's called now, is what they suggest using. So we're going to use the Universal Project Template. The reason why is it's already set up for Shadergraph. If you already have a project and you want to change it to be able to use Shadergraph, there are a couple of things that you have to do, and I've linked to that in this Getting Started section of this blog. There's a guide that walks you through how to do that. But since we're starting from scratch, I would suggest just opening the Universal Project Template. Resuming share. So, Kara, this is kind of what you were saying, that there's a bunch of stuff in the scene, right? Okay, before we even begin to tackle that, it seems as though Unity has reset my viewing layout, which I'm not a huge fan of. So what I'm going to do is walk you through how I set up my scene, just because that will be a little bit more comfortable for me while we do this. So I'm going to go into layouts and 2x3, which gives us both the scene window and the game window on the same page, so you don't have to keep switching back and forth between them. And then it gives us the hierarchy, project, and inspector. I like to have my hierarchy above my project, so I'm going to take the project and just drag it down below the hierarchy. Obviously, if this is new or confusing to you, you don't have to follow this at all, but it's the way that I like to do things. Just to double check, can everyone still see my screen? So, as Kara mentioned, there's a bunch of stuff in the scene, which we need basically none of. So, the order of operations that I use to delete the default scene is click on the example assets and just hit delete, and it'll delete everything from your scene, but there's still a bunch of stuff in your project which you also don't need. For example, the example assets. So I'm just going to delete those as well, and there's tutorial info that I don't need. I'm going to delete tutorial info, and then everything else kind of works as just a general project setup. We'll put our preset. We might not even need presets, but I'm going to keep it just in case. But we've got materials, scenes, scripts, and then settings, which we don't have to worry about. Okay, everyone happy? Fantastic. All right, we might as well just get started creating a render pipeline. A shader graph. So I'm going to go into materials because this is where I will keep both my shaders and my materials. Your project organization is entirely up to you. Some people split them, have a folder called shaders and a folder called materials, but I like to have them both next to each other. And because we have set up our scene in the universal project template, we can immediately just create a shader graph by going to create, shader, and then PBR graph. So to create, you right click, create, shader, PBR graph. A different type of shader graph is the unlit graph, which can be good for things like particle effects. It's a little bit lighter on the GPU and doesn't actually interface with the different lights in your scene, but the PBR graph is like the kind of standard default if you want something that's a lit material. So for now, I'm just going to call this a test shader, and it exists, which is great. We can double click on it, which will open up a new shader graph window. So this is the shader graph window, and by default, if you have your scene like mine, it might open up in the scene view, which I don't really like. So I'm going to move this window to the to the game window. This way I can edit my shaders and see the outcome immediately in the scene window. At the moment, nothing is happening because we haven't actually applied our shader to anything. The way that Unity does this is you have a shader, but then you also need to have a material that the shader is applied to. So in our case, there's two ways that you can add a shader to a material. You can either go create a material, call this test shader, and then drag and drop the shader onto the material. The other way, which is really cool, I'll just delete that for now, is if you right click on the shader name itself, if you hit create material, it's going to automatically link that shader to the material. You'll still have to rename it to something useful. Okay. So if we double click the material, we don't really see anything. And if we double click the shader, we'll get this shader graph. If, like me, you are currently limited to working on a laptop, this might be an incredibly unuseful window because it is very small and the real estate here is really obnoxious. There's a nice hidden trick, which is if you press Shift and Space with your mouse hovering over a window, you full screen whatever window you're hovering over. So that's a really, especially for shader graph where real estate is very important, you'll see me kind of hopping back between full screen and windowed view repeatedly. So right off the bat, let's talk about what's in this shader graph window. The first thing that's in the top left-hand corner, the most important, but perhaps button on this interface is the save asset. What's kind of stupid is that Shadergraph does not automatically save, and Control S or Command S or whatever your system interface is doesn't automatically save the shader graph. So you could be working for hours and hours and hours, banging your head against the screen saying, why isn't my shader working? What's wrong? What's wrong? And it's just because you haven't actually pressed this save button manually. On the right next to that shown project, we don't have to worry about any of these. I'm just going along this top menu right now. All the way on the right-hand side, there are two buttons which are by default enabled, the blackboard and the main preview. By clicking them, you kind of see what they are. The blackboard is the list of properties of your shader, and properties we'll go into a little bit later, but just for the information now, are the variables in your shader that are exposed to the material or to your interface. The things that the designer or the player can change. And the main preview, this is kind of like a best guess estimate of how your material is going to look. It doesn't always work because sometimes you are depending on things like the position in the world or where the camera is, and this preview doesn't really have any of those things. But sometimes it can give you a decent idea of what your shader will look like. Okay, any questions so far? Awesome. I have a note in here about the differences between PBR and unlit if you're interested in that, but for the sake of time, I'm just going to skip over those things. We spoke about creating material. So let's create a simple shader. Right now, all I want to do is kind of demonstrate that things work and highlight if there are any problems with anyone's interface. So the only thing that we're going to do is take this PBR master node, which is a bunch of inputs, and you might recognize them from playing around with the default materials in Unity, and try to add a color to the albedo. If anyone is lost at this point about what any of these things are, in that blog post, there is a little bit further down a description of what each of these are, at least the ones that are relevant for today. But I figured that as we go through them and as they come up, I will explain each. All right, so albedo is basically like the diffuse color. It's if you shine a light on your material, what does the material look like? So there's two ways to create a new node. You can either right-click and then say create node, or just press the spacebar, which will bring up this drop-down menu of all these different nodes that you can use, which you are welcome to explore in your own time. But right now, all I want is a color. The workflow is pretty simple. You just press space and then type in the name of the node that you want. So here we've got a color node. By default, it's black, but I'm going to, let's make this a little bit of like a dark reddish color, and drag from the out of this color, which you can see says 4, which means that there are 4 things, four values of this color. And by default, I think it's RGBA, so red, green, blue, and then alpha. And we're going to drag this onto the albedo. Now, those of you who are paying attention will see that the albedo only has 3 next to it. So albedo accepts a red, green, and blue value, but color is outputting the alpha as well. We don't necessarily have to deal with that as an issue because Unity knows that in general, you will sometimes want to take a 4 color value and convert it to a 3 color value. So if we just drag the out onto albedo, it's going to connect automatically, and the color of the node will highlight that you are changing things from a vector 4 to a vector 3. So now if we save this asset and then go back into our scene, we now have a material, test material, that looks kind of like it did in the material window, just right in the top over there. And if we create a, let's make a sphere in our scene and just drag the material onto the sphere. And hey, there we go. We've got like a kind of decent reddish material. Does anybody not have that when they follow these steps? Amazing. Just highlighting one more time. It's so important that it has its own section in the blog, which is the saving asset. You will forget at some point and wonder why your shader is not working, and you'll think back to this time and laugh. That's all well and good, right? But like what we've done is basically created the default material, but worse, because we've got a shader here, and in our object properties, we've got the material, but the material doesn't have anything, doesn't have any settings. So like, kind of what's the point? Unless we wanted to create a game or an experience where we absolutely know that it's always going to be red, this is a very unhelpful shader. What we want to do is, or at least in this case, I want to be able to at least change the color of the material, right? So what I was talking about earlier, the stuff that is in Blackboard is generally the stuff that's exposed to the materials inspector. And to expose it as a variable, or what Unity calls a property, you can right click on a node and just say convert to property. And that's going to convert this color from a node that exists only in the shader to a property that you can access outside of the shader as well. So there's three generally things to keep in mind with a property. The first is the name. So this name that's in a kind of like button icon, you can double click and rename. So I'm just going to call this my test color. And that name, once we save the asset and go back into the default scene view, in my material, this color is now exposed in the materials inspector. So we can change it. And this name that we create over here corresponds to the name that we see in the inspector. One other thing to note is once you have a node as a property, you can then use that in other places as well. So you can drag that name in and have multiple instances of that property doing different things in your shader. But in my case, it's only the color and it's only dealing with albedo. So back in my materials window, I can now change this my test color to something else and it will update that material, which is great. The other two things to pay attention to in this property window is the reference and the default. So default means it's the default color, the one that if you send your scene off to somebody else, that's the color that will start. So that can be important if you're setting up like a scene that you want to duplicate multiple times. The default is what it's going to come back to. And the other thing is the reference. So eventually, hopefully by the end of this workshop, we'll be doing things like changing materials dynamically using scripts. And the reference is basically the name of this property, but in code. So that's different to the name that is in the materials window. I just want to flag that at this point. We will discuss it in a little bit more detail later. Cool. Has everybody been able to replicate a sort of default shader in their scene and change the color of it? Okay, fantastic. Which is great and all, but like, why are we replicating the default shader but worse? So now let's actually make a shader that's a little bit more interesting that you can't necessarily make using the default shader or the default materials from Unity. So what we're going to be doing is creating like a sort of glowy outline shader that can be used for selections or highlighting things, or like if you like space and stuff, force fields and things like that. And I'm going to call it a glowy shader. So let's just go through that whole process again of creating a new shader. Let's make it a PBR, and I'm going to call this glowy shader, and then create a new material and drag the shader onto the material to apply it to that material. And you can always double check by clicking on the material and making sure that the shader that it's using is under Shadergraphs and then the shader name that you've created. Just for demonstration purposes, I'm also going to apply this material to the sphere that I have. You know what I'm going to do? I'm actually going to scratch that, keep the test material on the sphere, duplicate the sphere so that we have a nice record of what we're doing, and put this on to glowy. Okay, so one of the more like fun and easy to use nodes that are in the Shadergraph library is this node called a Fresnel. Some people might call it a Fresnel, but the bloke's name was Fresnel. And the Fresnel effect is generally, if you look at something straight on, it appears dark, and if you look at it from the side, it appears shiny. So if you think of like a piece of glass, as you rotate it towards the light, it becomes a little bit more shiny. And what we can do is if we drag it onto the, for example, the albedo, and then save. Oh, I'm in test shader. I'm an idiot. So that's actually a very good point for everyone to be aware of. Make sure you're in your new shader and not your old shader. But if we drag this for now onto something like albedo, then no matter what direction we look at the sphere from, because it's a sphere, the parts of the sphere that are kind of like facing towards us seem dark, and the parts that are facing away from us, so the stuff on the side, seems bright. And that's cool, but not the entire effect that we want to go for. Because one thing to note is that albedo is dependent on the light in your scene. So if we change the directional light, the look of the albedo still changes, right? I mean, the look of the Fresnel still changes, but I want this to be glowing regardless of whether it's in light or dark. So the way that we can set that up is by using the emission rather than the albedo. So albedo responds to light, emission does not respond to light. So if we change the out from the Fresnel to emission, and just for demonstration purposes, I'm going to turn albedo all the way down to black. Now once we save, regardless of which direction the light is facing, it's always going to be emitting this color, or this brightness. One thing to note here, in case it is not obvious, even though it's called emission, it's not actually emitting any light into the scene. We don't have real-time renderers capable of that on a grand scale yet. It's called emission, but it's like the internal light of this material rather than actually sending light out into the scene. All right, so let's look at the Fresnel shader, or the Fresnel node rather. There's the normal and the view direction, which we're going to completely ignore for now. They might make a little bit more sense later on in this workshop. And then there's the power, and whenever you see power, you can generally think of it as something like it's expecting, or if you're taking a value between 0 and 1, like we are in this Fresnel shader, so 0 being the darkest areas and 1 being the lightest areas, power in general just like raises that value to the power of something. And it's a way of changing the way that the gradient of that curve changes. So a power of 1 is a linear gradient, and then a power of 2 kind of crushes the blacks a little bit and makes it a bit of a sharper transition towards the lighter areas. And then if you go below 1, it kind of does the opposite effect, where the white areas are highlighted and the darker areas kind of get smushed down a bit. Does that make sense? Fantastic. The other thing that I promised you was that this would be a sort of outline shader, but right now we still have the sort of central mass of this object blocking light. So we're not getting much, well, I mean, we're getting a bit of an outline, but the center of the object is still visible. So what I want to do is find out a way if we can make the darker areas of this image see-through. And one thing that we can do for that, by default, no, but if we change the mask settings from opaque to transparent, then we can do that. And the way we change the settings of this shader is in the little gear icon next to this PBR master node. There is somewhere down here, surface, opaque, or transparent. Oh, and I just realized that I didn't really talk about navigating this interface at all, but I'm moving around by pressing my middle mouse button and dragging the scene around. The reason that surface is opaque by default is because transparent shaders are kind of graphics heavy. They render after everything else. So it's basically each time you have a transparent shader, you're saying like render the whole scene and then render the whole scene again. By default, they say don't do that because it's quite graphics intensive. But if you only have a couple of transparent things, then that's not too much of an issue. If we convert our object to our material to transparent and then save it, it still is not super see-through, right? There's sort of something happening there, but it's very faint and it's not working out. Can anybody anticipate why that is happening? Absolutely, yes it is. That's a great intuition. So further down on the PBR master node, there's this alpha, and then right below it there's alpha clip threshold. So if we start adjusting the alpha, you'll notice that if we drag the alpha below 0.5, the object disappears. And that's because of this alpha clip threshold. The clip threshold is saying if the alpha is below a certain point, just don't render anything. It's basically invisible. But we don't really want that because we want to have we want to have those low alpha values so the object seems sort of semi-transparent. So I'm just going to move that to 0. And now I can drag my alpha in and out and it'll sort of show the object fading in and out. Does that make sense? Sometimes this happens with Shadergraph where there's another bug that's quite familiar, that's quite well known, where if you try to rename something, everything in Shadergraph freezes. And if that happens, just full screen the window and then unfull screen it. If that doesn't work, sometimes you do need to restart Unity, which is annoying. The other thing that you could do is if these sort of panels next to it disappear, but you don't actually need the panels, then like, whatever, just, you know, deal with it. Right now, I'm just dragging this as a sort of, as a demonstration. But one thing that you can do is if you need to set alpha clip threshold to 0, but you don't have this little panel next to it, is create a new a new number node and then feed that number node in. Now, for those of you who are familiar with programming, you might expect for there to be some sort of float value, right? Unfortunately, there isn't, because Shadergraph is a little bit stupid. They call their floats vector ones. So a vector one is just an array of floats that has an amount of 1. And then you can pipe your vector 1 into your alpha clip threshold or your alpha and set it as you want it. But I'm not going to do that. I'm just going to keep my alpha clip threshold at 0. And as I drag my alpha in and out, my object becomes more and less opaque. Okay, so everyone following that? So one thing that I could do is set my alpha at 0.5, save the asset, and now my object is sort of like semi-transparent, right? Which kind of works, but it's also not exactly the effect that I'm going for. What I want to do is have the areas that are highlighted as bright and fully transparent and fully opaque, and the areas that are darker as completely transparent. So I can also drag the out of the Fresnel effect into my alpha. And what that's going to do is say, hey, bright areas, you have a high alpha. Dark areas, you don't have a high alpha. And once we update that, now the outside of my object has a nice solid outline, and the inside is completely transparent. Absolutely sure. So one thing that might be happening is alpha and alpha clip threshold are two separate things, and your alpha clip threshold needs to be at 0. By default, it's 0.5. Okay, are there any other questions about what we've just done? Cool, so just to kind of get everybody familiar with this workflow, I'm going to repeat some of the steps that I did for the default-ish shader. And what I want to do is I want to be able to change the color of this glowy texture, glowy shader, and then also change this, this power of this outline. So to do that, I'm going to create a new, by pressing space, vector 1, which is the equivalent of a float, drag it into power, right click, say convert to property. And once my system catches up, I now have this property which I can rename glow power. Since I'm not going to be affecting this by script, I'm just going to keep the reference at the same, and by default I'm going to say a power of 2. So it's just because I like that value. The other thing that I want to do is create a nice little color node. So create node color and take our out into the emission. So rather than just taking the emission directly from the Fresnel, I'm going to take it from the color and create a property from the color. I'm going to call this glow color, and I'll set the default as a nice like bluish blue. So a small side note, not super relevant to the workshop that we're doing today, but could be useful in whatever dealings you have with Unity, is because we are using the Universal Project template, and because we loaded up that template file from before, our scene is already set up with post-processing. So one of the workshops that I might be doing in the future is a post-processing workshop, and it's a hairy beast, so we don't have to get too much into it right now. But it means that things like high definition, high dynamic range are enabled by default. And this allows you to make a color, an RGB color that is more than 1, or more than in P5 language 255. By default, when we click on the color, this is all we get in the settings menu. But if we change to HDR, we get this intensity modifier as well. And as we pull the intensity up, this is like a multiplier for the color. So you can take the blue, and it's now like extra blue. And what's cool about this is if we save it, if we save the asset, go back into the scene, it gives us a nice kind of like glowy effect almost. Because part of the post-processing that's enabled by default is this bloom, and any color value that is higher than 1 starts like popping. It has this glow around it, or this bloom, as if you have some sort of like Instagram filter or something on it. So that's kind of cool. And now, because we created those properties in my glowy material, we have this option to adjust the power and adjust the color as well. All right, does that make sense for everyone? Fantastic. So how are we on time? Cool, we are an hour in, and we are done with the glowy shader. So the next thing that we're going to do is create the dissolve shader, which I don't actually have a version of ready to go, but it was in the GIF that I sent in the email. So this is another like pretty simple effect that you see a lot of like intro to Shadergraph tutorials cover, but it is like really cool to see it work and to create it with your own hands. So the effect that we're trying to go for is like an object that is invisible and then kind of like dissolves into the scene in some sort of magic ethereal way, and then we can get it to dissolve out of the scene in some sort of magic ethereal way as well. When I describe that to you, you might think, oh, we should be using transparency because it's going to go invisible and it's and have sections that are invisible and not. But we don't actually need the transparency because the object at no point will be like partially see-through. So this is partially to outline like when alpha clip threshold is useful and when alpha is useful. Alpha is useful with its transparency component when an object needs to be partially see-through. So something like glass, where it's going to have some reflection but also allow you to see through it, or something like water even. But alpha clip threshold is useful when some parts of the object are visible and some parts of the object are not. So for this new texture, what we're going to do is create, or new material, is we're going to create a new material, a new shader, sorry. And it's going to be a PBR graph, and we'll call it dissolve shader. And then I'm going to right click on it, say create material, just to add a material for it. I'm going to call that the dissolve material. And so we have, just to go over what we were doing just before the screens became an issue, we created a new PBR graph called dissolve shader, and then we attached that to a material called dissolve material. I'm also going to duplicate my glowy sphere and move it across to the side a little bit, and then drag on my dissolve material so that I have a nice new material to play around with. All right, in my dissolve graph, so previously we went into the gear icon and we changed surface to transparent. This time I want to make sure that the surface is opaque. So we don't have any transparency in this object. All we're doing is relying on this alpha clip threshold value. And essentially for every section of the object, if the alpha is above that section, it is visible, and if the alpha is below that section, it is invisible. The object is invisible. So when we just drag this X value, that's changing the value for the entire object. But what we want to do is change the alpha for certain sections of the image, certain sections of the object. For now, I'll just keep that as 1. So what we might want to do is you could create different patterns to deal with this. A sort of generic, general, and very robust pattern that people use is a noise pattern. So if we type in noise to the search window, there's 3 different types of noise sine wave, gradient, simple. I'm going to choose gradient. It's a little bit smoother than the simple noise. And just for demonstration purposes, I'm going to drag the gradient noise into the emission. This is sort of my workflow. I often do this because emission is not only good if you need to emit stuff into your scene, or if you need to change the apparent light of an object, but it's also good for debugging. If I turn my albedo down, because emission doesn't rely on light, we can kind of see how the texture is applying onto the material. So we'll talk a little bit more about this later, but what this is doing is it's essentially creating a texture. So an infinitely large 2D image texture that is then being wrapped onto this object. And the wrapping is not perfect. As you can see, there's like a seam over here along one side of the object, and then there's a seam on the other side along the other side of the object, and then it sort of crunches way up at the top, and the same thing at the bottom. Wrapping a 2D image onto a 3D object is very seldom perfect. You're often going to find that there is some sort of headache involved. For now, I'm just going to keep it as it is because it's good enough for us. But if we have time later, which we might not have time for, we will be talking about different ways to get around this. What I was trying to get at is if we create this gradient noise, we now have this like sort of nice gradient-y pattern around the object, and instead of just bringing that into the emission, if we bring it into the alpha, with our alpha clip threshold at 0.5, parts of the object are going to be visible, and parts of it are going to be invisible. So if I save my asset and go back into the scene, okay, does everybody get this on their scene? A sort of partially visible object. So one neat little quick trick that we can do is back in our settings, our PBR master settings, the gear icon. There is right at the bottom there is a little flag for two-sided. By default, Unity only renders things that are facing the camera, but if we hit two-sided, it will also render the things that are on the other side, the back faces it's called. It seems as though what happens is every time I open up Zoom to check in on everybody's delightful faces, you get the gray boxes, and then when I close Zoom, they go away. If everyone's okay with that, I'll just keep checking in every once in a while. Okay, that's a really good point. You might be having the same issue as we were having earlier. Next to your albedo name, is there a tiny little box? If you click on that box, do you get a color window appear? You don't. Interesting. Okay, so in that case, what you can do is right-click to create a new node and search for color, and then drag that color into your albedo. I absolutely have no idea why this is, but sometimes people are having issues with these little flags next to the node names, in which case you just have to create a separate node itself and drag it in. Does that make sense? All right, which is actually, I mean, this is not a terrible idea. Let's create a color and just add it as like a sort of dark red-ish color. Save, and now, as I said, I was only using emission as a sort of debugging tool. I don't want it in my actual shader, so I'm going to drag that away and remove the emission. So emission should be black at this point. And now I have a shader or a material that, based on this alpha clip threshold, some of it is red and some of it is not red. What do you mean by undo? Like, like disconnect? The way that I don't know if this is the legit way or not, but if you click on the little line, you can drag it away and just like drop. But then it thinks you're trying to create a new node, so it'll give you the window to create the new node. So I don't know if that's the actual way to do it, but that's the way that I think you can also... Yes, you can also click on the node to select, click on the arrow link to select it, and then press delete. So now here's where things get a little bit tricky, because there are two different ways, probably multiple different ways, that we can actually achieve what we want. And what we want is for these islands to grow and shrink, right? We want the islands to be able to grow to fill the entire object, or be able to shrink so that none of the object is visible. And the most straightforward way of doing that is just changing the alpha clip threshold value, right? So if we pull alpha clip threshold all the way to 0, or just below 0, it means that none of the alpha values are being clipped. So the entire object is visible. And then if we pull the alpha clip threshold to 1, anything below 1, which in this case is everything, is going to be clipped. So the entire object is invisible. So one thing that we could do is create a node of type vector1, drag that into alpha clip threshold, make this a property, move the bloody material preview out of the way, make this my clip threshold, save my asset, and now in my materials window, I'm going to rename this to solve. Under the material window, we have this clip threshold value that we can drag in and out. So that kind of achieves what we're going for. In fact, it entirely achieves what we're going for. The only problem is it makes an additional step that I want to do to make this really cool a little bit more difficult. So if you're happy with this as a shader, like, go ahead and save it, because it does everything it needs to, right? But what I want to do is find a way to make little outlines along the edge of these islands to make it really seem like it's magically dissolving in or something. And the way that I've set this up right now, that's slightly more difficult with this clip threshold value. So what I'm going to do is, or let me just take a pause at this point and say, does anybody have any questions about what I just did? Fantastic. Okay, so this is the sort of easy way, but it limits the potential of more stuff. So I'll show you the slightly more complicated way, which is to delete the alpha clip threshold and keep this at 0.5. Right, so all of our alpha values below 0.5 are going to be clipped. And then instead of changing the clip threshold value, I'm going to be changing the noise value that's coming in. So let's bring back the main preview window just to show you what's going on. So one thing that we could do is, there's a node called an add node, which is just like across the board, add values to whatever pixel we're rendering. So if we take the out, put it into add, then as we move the second value of add, we're basically adding, like if we say 0.5, we're adding 0.5 to everything in this gradient noise. And if we add 1, then the entire image appears white because even the darkest areas of black here are adding, having 1 added to them, which means that every single section of whatever 2D texture we're creating here is going to be 1 or above, which evaluates to being full bright. But if we add 0, obviously, it's the same image. So just to kind of explain a little bit what's going on in case it's not super clear, the little windows that you see under the node that you can expand and contract with the chevron arrows, this is kind of like the 2D representation of what your texture, what texture you're creating. There are other types of nodes which deal with, for example, the position, which deal with 3D, and those generally come with a circle to kind of represent a 3-dimensional space. We won't have to worry about those at the moment. But in general, if you see something that's a square under your node, you can think of it as dealing with a 2-dimensional texture or image. Back to the point of what we were doing. What add is doing is it's allowing us to just across the board add a certain value. So then we bring that output into the alpha. And now we're saying, hey, the whole image, make it brighter. And what do you think will happen if we make the whole image brighter, given that we're clipping values below 0.5? Does anyone have any intuitions? That's okay. Shaders are pretty non-intuitive. But in general, if we raise the overall values of across the board, there's going to be fewer values or fewer sections of the image that are below 0.5, right? So the islands are going to, the visible islands are going to grow because there'll be less that's actually clipped. So if we move that up, more of the image, or less of the image is below 0.5, and if we move this down, more of the image is below 0.5. So if we kind of just generally ballpark this and see what's going on here, once we're above kind of 0.7, then our image is completely opaque, and once we're below kind of minus 0.7, then the image is completely transparent. Which means that now, instead of exposing the alpha clip threshold property, we can just expose this, whatever's being added in here. So I'm going to create a node, call it vector1, or a node of type vector1, bring it into the add, and expose this as a property. Bring back my Blackboard window. Since I'm not using clip threshold anymore, I'm just going to delete it to avoid confusion, and we'll call this dissolve amount. So once I save that, go back into my scene. I've changed clip threshold to dissolve amount, which sort of makes a little bit more sense to me intuitively. Like -1 gives us, it's like this, where we're completely on the negative transparent, and then if we drag it up to 1, then we're completely on the positive on the opaque. One little quick trick that we can do here is dragging this value works sort of, but I wish there was an interface that we could use, like some sort of, what do you call it, like a slider, right? Well, good news, there is. In our Blackboard, which is the window that's by default over to the left, under mode, if you have a vector1 specifically, you can have a couple of different types of modes, and you can create a slider, and set the default minimum and maximum values. Now, for us, we don't want the default minimum to be 0. We want it to be -1 because that's the kind of range that we've established works as our dissolve shader. So now in dissolve amount, we've got a nice little slider to interface with. How is everyone following? Feeling good? So the next thing, the reason that we're doing this, setting the nodes up this way using the add node rather than directly into alpha clip threshold, is now we know that everything, like basically the intersection of art and technology. No, I mean the intersection between opaque and transparent here will always be 0.5 because that's the point at which we stop rendering, which means that everything just to the sort of opaque side of this will be just above 0.5, right? And everything to the transparent side will be just below 0.5. And as we get to the more central areas, something that's like right in the middle here will be a higher value, higher alpha value than something closer to the edge. Does that make sense? I feel like that's a little bit of a conceptual leap. So how does that feel on everybody, like intuitively? Okay, cool. So what we can do with that is we can say, hey, for areas that are like 0.6 alpha, make them really bright on the emission scale, and then as we get higher, we can sort of make them a little bit darker. So once I hide this window, I have an intuition that if I have a range of values between 0 and 1, and I want a certain like sub-range of values between, for example, 0.5 and 0.6 to be doing something, to be have some sort of color associated. A great way to do that, whether it's in these shader things or in Unity in general, using the scene viewer and stuff, the kind of mechanism for doing that is using a gradient. And we have a special node, well, it's not that special, called a gradient node. And what that does is it just gives us the ability to create a gradient. And I don't know why they say they use location, and I don't know why they use % either, but what a gradient is doing is saying for a range of values between 0% in this case and then 100%, set up a gradient of colors. And we can create new colors in the middle. So in this case, we'll have a gradient that moves from 0%, where the attached value is, the gradient box. So once you've created the gradient, click on the little color bar. Essentially, the gradient is a way to map a floating point number from 0 to 1 to some sort of color. So 0 is on the far left. For this particular gradient, on the far left, 0 evaluates to complete white. Right in the middle, so like 0.5, evaluates to pure red. And then right on the far side, so around 1, the color value evaluated would be blackish. Does that sort of make sense? Okay, fantastic, thank you. So what this means is kind of in terms of what we were looking for, what I was trying to do was say values that are around 0.5 should be some sort of bright bluish or reddish or yellowish or something, and then immediately kind of fade off, because I only want a thin outline. I don't want it to be the whole island. I'm calling the opaque areas here along the areas that are visible islands for some reason. Yes, I want areas that are around 0.5. So let's go back into this gradient. Areas that are around 0.5 to be very bright. So I'll pull this brightness up to around 50%. And then I want that to quickly fade off into darkness. So at around, let's say, 65%. Now, in this specific case, it doesn't really matter what's on the right-hand side of that, the left-hand side. It doesn't matter what's below 0.5, because that's not rendering, right? 0.5 and below is completely cut off. We don't even have to worry about that. For the purposes of today, we're only worrying about this tiny little section between 0.5 and 0.6. Okay, and that's all well and good, but like, what do you do with that, right? Because this output is a G, and that doesn't really go into anything. We can't feed it into any of these nodes. So at the moment, it's kind of useless. What we need to do is we need to find a node that says, okay, take a value and evaluate the gradient at some point, or evaluate that value at some point along the gradient. In Unity scripting in C#, they call it gradient.evaluate, but in this shader language, they call it sample gradient for some reason. So the idea of this node is, say, they also call the value that they're evaluating time for some reason. But essentially, time expects a value between 0 and 1, and it will evaluate, sample along this gradient curve where whatever value you give it. So 0 will evaluate to fully white, 1 will evaluate to fully black, and then this kind of central area will evaluate to somewhere in between. So if we feed in the gradient to the gradient input node, and then we feed in this add output into time, as we increase and decrease, oh, there's no way to easily do that, damn. But if we start changing the default from 0 to 0.5, you can see that the areas that are lit start getting smaller and smaller. That's not super intuitive at the moment, but what I want to do is take the output of this sample gradient, put it into emission just to see what will happen. And now we can see that the outlines, hopefully this gives you a little bit more intuition into what's actually happening. So the areas that are 0.5 alpha that we're getting from this alpha, it's not exactly alpha because the alpha, we're setting the alpha in this master node, but it's just the value that's coming into the alpha is also coming into the sample gradient. And areas that are 0.5 are pure white, and then quickly dropping off to pure black. And because it is an emission and not an albedo, we don't actually see that black. Black just means don't emit anything, so it's kind of like invisible. All right, let's save that, go into our scene, and just as we expected, or rather just as I expected, as we drag in the shader, the object kind of dissolves in and out. That was a lot, so I'm going to go back to the shader graph, show you the node setup that I created, and field any questions that might have come up during that. So the sample gradient is essentially what we're using to evaluate the gradient, right? And when we bring in some sort of value between 0 and 1, sample gradient is saying, okay, if let's say the value is 0, it's saying take this gradient and output whatever color is at 0. If the time coming in was 0.5, it's going to look at exactly halfway point of the gradient and show you and output whatever color is at 0.5. So the reason that I made this tiny little band of colors over here is because this is the band of values coming in from my add node that are, I keep losing it. That's going to represent right at the edge of the islands. If, for example, we move the band further up into the sort of higher numbers, it means that more of the island is going to be on the brighter side of this gradient. Does that begin to make sense? I guess the thing to remember is that we're using this in combination with the alpha clip threshold. So alpha clip threshold is saying throw away values between 0, throw away any values between 0.5. We're saying this add node over here has this noise which is between 0 and 1, and then we are adding the dissolve amount which is between -1 and 1. So essentially what we're doing by using this dissolve amount is shifting where that 0.5 is, whether the 0.5 is like really high in the image. Let me just disconnect this for a second. Yeah, as we're adding like a sort of uniform value, the areas that are below 0.5 shrink. And then as we remove a value, the areas that are below 0.5 grow. So we're using this gradient to just say, find the areas that are around that 0.5 and do something interesting with them. Create create a brighter color around there. All right, is there anything else that's unclear or that you'd like me to go over again? Okay, cool. Moving on to access things via script. Earlier, I kind of briefly glossed over the fact that in our properties window, so in the blackboard, which they call it in Unity, we have a couple of things to pay attention to. The first is, so for example, in this shader, I have only one property exposed, which is the dissolve amount. I might actually want to expose my color as well, just so that we have two things to play around with. So there's a couple of things to pay attention to on the properties window. The first is the name that appears in the inspector, which is this guy over here. So that's we've got dissolve amount. The second thing is the reference, which is how we access it in code. And then the third is the default, which we all know about at this point. So the reference is usually some sort of ridiculous number, or the name of it plus some ridiculous number, but you are welcome to click on that and rename it to something a little bit useful. I'm going to call it dissolve amount ref. In some of the older versions of Unity and the Unity documentation, you might see people start the reference with an underscore. I think that's some sort of shader convention that I'm not aware of. Because we are only programming for ourselves, we don't necessarily have to obey conventions, so I'm just going to call this reference. All right, so then back in our materials, in our scene, we've got this object called dissolve with our dissolve material attached, right? So I'm going to create a script, and I'm going to call this script dissolve handler. My naming convention is whenever script does something or like manages some property of something, I'll use the tag handler. Other people you might see call their scripts manager or things like that, but handler is the term that I use. And if we double click on that, wait for Visual Studio to load, we'll talk through getting the properties of the material. So I'll give everybody a second just to have their code editor of choice opened. In this class, all I want to do is I don't want anything to happen in start, and I don't want anything to happen in update either, so I'm just going to remove all of those, and I'm going to say field material. Sorry, I think with my hand. So what's happening here is serialized field, for those of you who might not have seen this before, it's a way of exposing a variable to the inspector without making it public. So you could also have just said public material. And then we're asking for a material, not the shader itself. So when you run your code, there will only ever be one shader, but there can be multiple materials with different instances of that shader, or rather different instances of the material. So the material that I'm asking for is a dissolve material. So I'm just going to save that, go back into my scene, and now it wants me to drag in whatever material I'm dealing with, whatever material I want to change. So I'm going to drag in the material from my dissolve object. No, I'm not. I'm going to drag in the material from my dissolve object by dragging in the material name there. You could have also in start said dissolve material equals get component, and then you have to find the renderer, and then you say the renderer dot material, and that will give you the material as well, but it's a little bit clunky, so I just use the inspector to say, hey, give me the... It's a little bit of more manual work because I have to drag in the material, but it means less coding. Okay. Now what I'm going to do is I could write something in update, but this is the dissolve handler, and all I wanted to do is have a function that changes the property in the material. Right, so I'm going to create a public function so that any other function, any other script in my scene can access it, and it's not going to return anything, so it's a void script. And I'm going to call this on something on dissolve value change, and it's going to ask for a float, or we can even be more explicit about this and say new value. So what I'm optimistically doing is I'm setting up a function called onDissolveValueChanged, which kind of highlights what the function or when this function is going to be called, right? It's going to be called when the value changes. And what I have to do is pass in a new value to this. When this function is called, it's going to take the dissolve material and it's going to set float. So there's a couple of different things that we can set, and those things are, if you ever want a reference for all of them, in the Shadergraph view, in this little blackboard icon, there's a little plus arrow right to the top right-hand side. If you click that plus arrow, this shows you all the different data types that... So the little plus arrow shows you all of the data types that are available as properties. So we have a vector1, and then we have some colors, textures, booleans. I did mention earlier that for some reason Shadergraph calls floats vector1s, and we just have to kind of deal with that. So in our script, all we've done is say set float, and now you use as a string the reference of your that reference name, which we called dissolve amount reference, and we have to set it as the value coming in. So it's only 3 lines of code, but it does take a little bit of like getting used to which parts are moving where. How are people following so far? All right. Well, of course, if we run this now, nothing is going to happen, right? Because we've set up our function, but we're never actually calling it anywhere. So one way that we can quickly just test whether this function works is, say, in a start function, say, call the function by saying on dissolve value changed and set it as, what do we want? Something like 0. So this will ensure that whenever we run our scene, let's just have a look. So the dissolve amount, let's turn it up to like 0.6. And now when we run this, dissolve amount does not change because why? What did I do? Uh-oh. Let me briefly consult my notes over here. I don't think I saved my asset. Thank you. That is a very astute observation. But yes, Kara, I think what you have said is probably what's going on, which is a little bit of an unfortunate thing. Like as I said at the very beginning of this whole thing, the CPU does some stuff, then sends it off to the GPU, which never talks back. It's like, go take this and run with it. Which means that debugging is really difficult because right now there was no like, oh, couldn't find this reference. It was just, it like tried to send it off and that didn't work, so that was the end of it. Let's see if that fixes things. This is one of those cases where I promise it worked earlier. There we go. Yeah, so now when we start this, if we change this on, if we change the start value to something like -1, and then run the code again. Now when we start, the dissolve amount is set to -1, and we can manually drag it. So at this point, we kind of get outside of the scope of this workshop because anything from here onwards is more of a scripting exercise than it is a shader exercise. But some things that you could do with this is you could set up a, you could set up some sort of like sign function here, where we say like float, oh my goodness, this is way outside of the scope of this workshop. Time. Let's do it that way. And then on dissolve value change. So what I'm doing here is I'm saying just evaluate the time that the sketch has been running by onto a sign function. So it'll sign backwards and forwards between -1 and 1. Then send that value to my change. Actually, on dissolve value changed is probably not the right thing to call this. It should be called change dissolve value or something. But when we run this, hopefully this is untested. Yeah, now it's sine waving back and forth between -1 and 1. And after this, the world is your oyster. You can kind of do whatever you want. In the example project that's on GitHub, what I did is I set instead of changing this by script, and I'll just mention this so that you know it's possible. instead of changing the value by script, I set it using a user interface slider. And it's actually pretty simple to do that, so maybe we can do that in the last 3 minutes. If you create a UI slider, under the slider values in the inspector, you essentially have this collection of parameters to change, and the ones that we might want to pay attention to are the minimum value, the maximum value, and then this on value changed list. So since we know our shader expects between -1 and 1, we can say -1 is the minimum value, 1 is the max, and then on value changed is a set of functions that will fire when you change the slider value. So we can find or even drag in our dissolve object and then find a function on that dissolve object somewhere in its collection of scripts attached. So there's the dissolve handler script, and then because we created this public, because we made it public, it has to be public, function on dissolve value change. One thing that's kind of not super clear is this function is tagged under the dynamic float, which means that Unity has automatically detected that this function takes in a float. And because the slider is a float, it's saying, hey, give the slider value. So we don't actually have to set that up other than writing the function that we did earlier. Unity handles that automatically for us. And now, let's just make sure our slider is in some useful place. Yeah, and we'll make it really wide. And just move it up a little bit. Now we have the slider that when we run the scene controls our shader. But yeah, now that it's exposed to whatever function that you need it to be exposed to, the sort of world is your oyster. All right. Well, I'm afraid that brings our workshop to an unceremonious end because it is exactly 5 o'clock Chicago time.